Okay, I'm very glad to be here with all your robotic people here. And I will talk about the dawn of a new algae-based marine industry in Sweden. First, I will take you through why do we need algae for a sustainable future. Then I will tell you a little bit about a big project that we are running and how we deal with the algae and how the algae industry is growing. And finally, I will tell you a bit about why we need autonomous underwater vehicles to support the future algae farmers. Let's start here. This is the European Union strategy for the future, for the sustainable future. And the thing is that on land, we have reached the carrying capacity of the system. There is not much more we could do on land. Human beings are taking most of the fertile land, most of the resources on land for just one species. The big potential for a future economical growth lies in the ocean. So we have to unlock the potential of the ocean. And then we need to do it in a sustainable way. But we have been the oceans, we have utilized them in a very unsustainable way until now. We need to do it in a sustainable way. So sustainability is a very critical issue here. And what we could do in the oceans in the future is to put out energy system, wind farms, wave farms. We could put out aquaculture, food production. We don't need to irrigate it. We don't need to put any fertilizers. And this is, from a climate point of view and a sustainable point of view, very fruitful. And algae will be a very important part of this. Okay. Here we go. We could start this algae tour now by going to Korea. And this is on the Jeju Island in South Korea. And here we have the hyenos, these women that dive. And they have, in a very sustainable way, for hundreds of years, been collecting seafood from the ocean in a very selective way. And here they collect algae. And it's only the women who support the family here. This is a very sustainable way of catching things from the ocean. And then we have the opposite thing here. I don't know why this one. Here. This is from Brittany in France, where they love algae, and they have a lot of nice algae things I will show you later. But the thing is that they do wild harvesting of algae, so they drag the algae out there. So this is just taking up everything, and when they harvest the kelp here. Here, to do this wild harvesting is not the sustainable future. We need to cultivate the algae in order to do it in a sustainable way. And then we created a sea farm project, and this is macroalgae or kelp for a Swedish bio-based society. And this is how we're going to turn from a fossil-based industry to a bio-based industry by using the biomass of algae. And in order to fulfill this big project supported by the Swedish Research Council, and KTH is the leading partner here and I'm the project leader, we had to go to look for Chalmers that have the food technology. It's another technical university. We had to find knowledge at Gothenburg University that have the marine botanists. We had to have Linnaeus University with us working with biogas. And we had Lund University looking on the socio-economical aspects of this. So in a country in Sweden, not one university could manage to do this. We have to cooperate with many universities and also having industrial partners. I don't know if you see it, but this is our sea farm now. This is 2 hectares. We have the sea farm located in the only Swedish marine national park up towards the Norwegian border. And this is deliberately, we want to have this type of things also in marine protected areas in order to show that you also could live in a sustainable way in the sea. So we have a dialogue with the local people here. And this is the first big, could you say, commercial sea farm, algae farm in Sweden. Yeah, here we go. This is now, we have been working with this for about 5 years in the Sea Farm project, and now there are spin-offs, companies is coming, and I could say that we are now slowly developing a new industry based on algae cultivation. And I will also show what we could do with all the algae. So this is just harvesting feast on the blue farms in the sea. That's what is said there. I don't like this one actually. Yeah, I mean our project have been selected. It has been very much noise around it. We have been selected as one of the 10 botanical projects that may change the world. So it's kind of hard pressure on us. It has been selected as one of the best sustainable cases for a sustainable change by the Nordic ministers in the Nordic countries. And first, before we come into the algae, I would like to show you why we don't want to do wild harvesting, and that is not the thing. So I'm going to show you what we are working with. We're always working when we cultivate the algae with local populations. And this is how it looks in the North Atlantic. So you just get a feeling for the very nice marine environment. And high biodiversity in this kelp forest, these underwater forests. And we are dealing with all the different colors of algae. We are doing the brown algae, the kelp, we are doing the green algae, and we're also working with red algae in our project. And then what can we do with algae? We could do very many things with algae, and I will just very fast show you what we could do. We could use algae as insulation in construction. This is from Denmark, and it's used today also. It's a long tradition, but it's still used. This is from an Australian company where they make bricks that are very sustainable and very long-lived. And this is also when you use algae to do this kind of construction material, you also lock in the carbon. And it could be a carbon sink for a while. You could make clothes. Would you like to have this dress? Very beautiful dress. This is algae, but you could also make from the polymer, you could make fibers and t-shirts and things. And this is a very important thing because textiles and cotton industry is very polluting industry. So you could use algae for textiles. You could extract colors from algae. They have all these brown, red, green colors. And you could extract it and get the colors out from the algae. And that is high-value products. I don't know if you know Smarties, these little things, candies that you eat. There used to be a blue one there, but this blue color was an artificial color. And then when you eat it, kids get very overactive. So they banned it. But now they have extracted a new blue color from algae that don't make super active kids. So you see, another big industry that could be algae-based are of course cosmetics. And the algae, these colors are also antioxidants. And here you could just put it in a bucket, you put it in your face, you become 10 years younger, and then you charge $50 for it. A very good industry. And then eating algae. I mean, there is more and more popular ways of eating algae. This is an Irish medical doctor, Penny Radigans, that have made this very nice cookbook about algae. And she also talks about all the good things that you have in algae, because algae contains most of the things we need as human beings. And I know that we are many intelligent people here, maybe not me, but you. And then you should think a little bit about that your ancestors in Africa, once upon a time, were living on the shores, going out, collecting seafood, getting nutritional fatty acids, omega-3 fats that made your brain grow, and we became intelligent. And most likely this was algae. And brains are more or less looking like an alginate, an algae. So think about that. You are intelligent because your ancestors were eating algae. And And now this is becoming very popular. So in the Sea Farm project that I'm working with, we also have a cooperation with chefs, and we make different dishes of algae and try to promote algae as food. And the interest in the Asian cuisine makes it many people are very attractive of eating algae. And since it's also a very nutritional, valuable food, it's also good for vegetarians. And in Germany, for example, there are 16 million people that are vegetarian right now. These are only some products out on the market. This is a Algae Caviar replacing rum from fish. This is from Brittany. They do all the nice French things. They do cheese, they do everything based on algae in Brittany. So if you go to Roscoff and this area, algae you will see it all over the place. This is one of the first products in Sweden now based on the algae produced from our farm. And this is a juicy hamburger or algae burger made of algae. And this was advertised all over Stockholm. And then we could do art of algae. And this is a cooperation we have with the Aalto University in Helsinki. And here is Department of Seaweed, it's called. And there is sculptures and art and different creative design things based on algae. So you see, there are so many things you could do with algae. And I say, this is the new oil. We could do everything that we could do with oil, we could do with algae, but we could also eat it. So let's now have a look on the Sea Farm project. This is what we have been doing in our quite big project, and we are many people involved in this. First of all, we are doing cultivation, seeing how could we cultivate and guarantee the production of algae biomass from year to year. So cultivation and harvesting techniques have been very important. Then we have, this is a quite sensitive material, the biomass, so we need to work with the storage and preservation of the algae. So we have done that. Shall we freeze it? Should we dry it? What should we do with it? And then the biomass goes to the biorefinery that are located at Chalmers Technical University and at the Royal Institute of Technology, KTH. And then we do food and feed additives, and we do bio-based materials, such as replacing plastic material, paper, adhesives, etc. And this is what we are doing at KTH. On the residuals from the biorefinery, we have energy extraction in form of biogas. And from the residuals from the biogas, we do biofertilizers, doing experiments to use algae as a fertilizer instead of industrial fertilizers. And eventually we'll have a leakage out from the society, but the nutrients will be taken up by the algae cultivation. And then least but not last is my research group. We are working with sustainability assessments. We look in the environmental aspect, the technical constraints, the potential in Sweden, the socio-economical, how many jobs could be created, etc. by using algae. So, this is the Sea Farm project in a nutshell. And let's go in now into the Sea Farm project and see a little bit what we are doing there. First of all, algae are a little tricky things because they have life cycles that are quite complicated. Some are easy to cultivate, others are more difficult. But the algae, in this case, the kelp you see there, it's called a sporophyte. And it will release zoospores into the water, and you will have female gametophyte and males gametophytes that eventually will evolve into sperms and eggs. So here they are a little bit like animals, you could say. You will get the fertilization, and then you will get a little small sporophyte that will attach to the bottom, and then it will grow. This first part, when you cultivate algae, you do it indoors in the laboratory, and you have ropes that are about 200 meters in length, and you have this seeding on the ropes with small plants, you could say. And they are only a few millimeters. But after a couple of weeks indoors, you deploy the algae ropes out at sea, and then you do it on a thicker rope. And here you could see the thin rope that is covered with the sporophytes, and then we put it on this big rope out at the sea farm. And then, just 5 months later, from being a few millimeters when deployed out in the sea, they are now 3 meters tall. And that's why algae biomass are so interesting, because there is nothing growing this fast. I mean, it grows faster than bamboo. So you could literally see the algae grow, and you could produce huge amount of biomass. And in Sweden, we have quite eutrophicated water, and that means that we don't need to put any fertilizer or anything. We don't need to irrigate it during a dry summer. We are not taking any fertile land, so it's no competition there. So there they are. So if we want to go from a fossil-based society to a bio-based society, we just have to rely on forests. We have to rely on the sea forest, the algae, and maybe some rest products from agriculture. And that's it. And this is, of course, essential that we do, because otherwise, yeah, you know Greta Thunberg, you know what she says, the Swedish girl. Have you heard about her? Yeah, 7 million on strike now. So she likes algae. Anyway, this is the sea farm, and now this is from this year harvest, and we are working on industrializing this, doing it big scale, taking up the algae. We are working with taking it in different drying techniques we are doing experiments with. And here you could see they are only 5 months. We deployed them in October, November, and we harvest in the beginning of April. So here you could see how tall they are, the algae. And then we are, of course, a bit happy because for the first time, aquaculture in Sweden could compete with Norway. We like that. And we could compete with the Faroe Islands. And that is good. They don't produce more. We have a super production. And for once in a while, we could sink the Baltic Sea and all the nutrients coming from there that we are utilizing in this cultivation. So I will also take you a bit showing the biorefinery part of it and what we are doing there. I mean, we are working with integrated biorefineries to produce, improve, you could see the economical value in each step of the process chain. And we are dealing for food, fine chemicals, bio-based materials, and feed for animals. That's what we are focusing on. Energy is a secondary thing. And this is just, we want to produce as much biogas that could compensate for the energy that was put into the system. So we could argue that it's energy neutral. We are not working with pharmaceuticals. That is a very expensive thing. But there are a lot of valuable things in algae for that branch too. Anyway, this is what's happening. The algae comes in to the biorefineries at KTH, in this case first. And there we make a separation. We have the protein, the lipids, things that go for food will be go down to Chalmers, and they will work with the food technology there. And we will focus on different kinds of green material, creating alternatives to plastics, for example. This is just one example. It looks very primitive, but it's made from the algae. Have you been to the dentist? You go to the dentist, and there are this little disposable cup, you know, that you rinse your mouth with at the dentist. In Sweden, we use 50 million of these cups every year. So we just started a project now doing alginate cups. So after you have been on the dentist here, you could eat up your little mug. Just eat it. This is, of course, without all the problems with plastics and so on that you have. And this is, even if our disposable cups will be much more expensive, maybe 2 crowns. And I mean, I don't know what that is in euro, but anyway, it's much more expensive. But a visit to the dentist is very, very expensive in itself. So this doesn't matter, the price here. Anyway, we are doing other things in the biorefinery. We are doing ethanol. The algae here, the kelp, is very rich in sugars, much richer than sugar in itself, or sugar cane. So you could make ethanol if you want from the algae, works fine. But we are also working with proteins, the lipids. We do characterization studies, stability, digestibility, to see if it works for feed, for salmon, for example. And we're also working with all the minerals, vitamins, the antioxidants. And at Chalmers, they are working on creating a very good functional ingredient, like a nutritional bar or something that could be eaten, that could be good to enrich food with algae. Anyway, now we are coming closer to where the autonomous underwater vehicles are, could be used. This is a geographical information system study where we have put layers of different types of competition that we have on our coast. The Swedish west coast here is a very attractive coast. There is a lot of tourists coming here. It's actually very warm in the water in the summer, nearly as warm as you have here actually. So people love to be there, but it's only for 5 weeks. Then it closes down, and there is a lot of rich people living here, and they don't want to have anything that disturbs them when they come here to their country houses. So we have put layers here, so we don't want to compete, so we don't have it in the inner archipelago, very attractive. We have to compete with military areas, we have to compete with Natura 2000, national parks, etc. Transportation lanes where you are going with the boats. This is a very attractive coast for sailing and so on. But then eventually these red areas are areas that are not in competition with all these other things. So this is the potential on the Swedish west coast, from Gothenburg up to Norway, where you could cultivate algae. And if we were doing this, cultivating algae on all this area, this would be a multi-billion-dollar industry in Sweden, if we do that. We are not there yet, but maybe in the future. This is just to show you how it looks in China, in Korea, in Japan, that have been doing this for hundreds of years, cultivating algae. And these are algae farms, very concentrated. We don't believe that we will have this type of algae farms in Sweden as dense as this. We are aiming for about 10 hectare size plots dispersed on this coast. And a 10 hectare spot of an algae farm will generate about 1.2 million euros every year. So it's kind of, and this is only for the biomass, wet biomass, not for the, if you do some valuable products out of the biomass. So it is very profitable to cultivate algae. Anyway, since the farms are located far out in the archipelago, you need to have expensive things to go there. This is the new research vessel, Swedish. It just came a couple of weeks ago. It's called Svea. And this is for meteorological, hydrological studies and fishery studies. Expensive. It cost actually 25,000 euro per day, this boat. That's how it costs. Very expensive with boats. Maybe we don't need that size boat to go out to the algae farm, but if we need it, it will anyway be a boat and it will be expensive. And then you need to have, to check these farms, you need to have divers. And this is a bit how it looks underwater. Checking the production and so on, and see that it's all right, that after a storm or something, that nothing have destroyed the farm. Very expensive also, at least in Sweden, to have divers. So why not work with autonomous underwater vehicles that could be a help in algae farming. And then we have this very nice project SMARC, Swedish Maritime Robotics Center, that I'm also a part of, but more like an end user. And we have tried now and developed ways of seeing if we could construct one of these smaller robots that could help in doing inspection, analysis of the production, etc., of the algae farms. And then I could say that I have a dream that in the future, when we get these 10-hectare farms out there in the archipelago, we could also have a robot or an AUV that will be there, do maybe daily or weekly inspections of the farm, sending information about the status. Already maybe in January or February could measure the size of the algae, and we could estimate the production from the farm that will be when we harvest in April, May. And then you could negotiate with the customers and say, oh, this is the production. So we have lots of ideas of what to do with these robots in the future. And then we thought this was very bright, that, we could have AUVs in algae farms, and there will be a lot of algae production in the future. I'm quite convinced there will be a lot of farms in the North Atlantic, and this will develop more and more. But I was not the only one having a dream. Also in the US, this is outside the Nantucket Island. They have ideas. It's not there yet, but they want to invest quite big in algae farms here in the United States. And they also thought about this independently from us, that they could use an AUV like this, monitoring the algae farm, see if the rig have survived a severe storm, measurements and so on, and also could be recharged in a docking station on the bottom and sending information. Yeah. So now I hope that I had convinced you that algae is part of a sustainable future. You will hear much more about algae farmings, and it will be developed. There is big trials now with algae farming in Norway, in Scotland, Ireland, Denmark, Sweden, Faroe Islands, Alaska, Greenland, Maine, Boston, and also the Pacific part of the United States and Canada. So this is growing, and it will be a very important industry for the future. And could we develop autonomous underwater vehicles that could support and help these algae farmers in the future? I think that could be a very good thing. The current focus on the global seaweed industry have been on pharma, specialized compounds, and food and feed. But if we are going actually to go from a fossil-based society to a bio-based society that is necessary for our future, we also have to consider biomaterials, energy, and fertilizers. And all this you could get from algae. Sweden doesn't have this huge maritime space, but we have enough to produce quite a lot anyway. But other countries have, of course, much more space. But there will be plenty of room for algae farms in the sea in the future. From Sweden, there have also been a spin-off. The first commercial company now is a spin-off from our research. It's called Koster Algae, and produce algae commercially now. For everybody who wants to do something with algae, they could get sustainable cultivated algae from Koster Algae. And this is also organic labeled, this production that we have from this company. So if you're interested in algae and more about sea farm and also about what we are doing in SMARC, I mean, you could follow this on seafarm.se or on smark.se. There will be more and more information about what we are doing in the future. So with that, yeah, I was fast. Yeah, I have 15 minutes left. But anyway, then we could have time for questions if you have any. Thank you.